Today we're going to start 2.6b. It's got a lot of topics in there. Well, not a lot of topics, but some of them are kind of difficult. So it's actually going to take us 2 days to get through this. I want to start with creating quadratics from the same factor. So what would the quadratics look like? Well, we would need to write it twice and distribute it out. And I get x squared minus 4x minus 4x plus 16. And that simplifies to be x squared minus 8x plus 16. Okay? Can you do that one in your head? What would it be? X squared plus 2 copies of 6x, so it would be 12x plus 36. Okay, hopefully you see the pattern. So the next one is going to be x squared minus 20x plus 100. Okay, so what's the pattern? If we have the same factor twice, then this number will be twice as big as that. And that number will be the square of this. And that happens in both cases, in all cases. 6 times 2, 6 times 6. Negative 10 times 2, negative 10 times negative 10 squared, sorry. Okay. So, if I had a quadratic that said 4 times x minus 3 squared plus 2, where is that quadratic? Well, it's right 3, 4 times as tall, and up 2. So it's going to look like that. Okay? Actually, let's do, well, whatever. But if I wanted to know, let's say it was negative 4. That makes more sense. Let's say I wanted to know where it hit the x-axis. I would need to use a different form of that equation. So this form right here is called vertex form because it's really easy to find the vertex. The other form, the one that we use for factoring, is called standard form. So how do you convert vertex form into standard form? Well, it's really easy. We just multiply out the x minus 3's and then simplify. So hopefully you're really good at this now. What is that going to give us? X squared minus 6x plus 9 plus 2. So I put in the 4. 4x squared minus 24x plus 36 plus 2 becomes plus 38. So that is referred to as standard form. It's the exact same equation. If you were to plug those two equations in your calculator and push graph, you wouldn't be able to tell the difference between them. Okay? They're just wearing different clothes. Same person, different clothing. Okay? So going from vertex to standard form is really easy. But going from standard form to vertex is more complicated. So let's say I started off with x squared minus 8x plus, I'll say 10. Okay. Well, I need to force this to look like that. Does it follow the pattern of being a perfect square trinomial? No. In a perfect square trinomial, this divided by 2 times itself would be that. It's not the case. So what I'm going to do is bump the 10 out of the way. And I get x squared minus 8x. I'm going to leave a space plus 10. Now I will force this to be a perfect square. If this number is an 8, what would go in here? it would be half as big. It would be a 4, minus 4. And if this is a minus 4, what goes in that space? 16. So I had a perfectly balanced equation. And as long as I do the same thing on one side that I do on the other, it remains balanced. But now, all of a sudden, I have added 16 pounds to the right side. How do I put everything back in balance? Good. I could add 16 to the left and it would be balanced out, but I don't want anything on that left side. So when I add 16 to the right, I want to subtract 16 from the right and everything will be balanced. But instead of subtracting it here, I'm going to subtract over there. And now my equation is in vertex form. And I did that using what is called completing the square. I forced it to be a perfect square and then just adapted that constant on the other side. So where is this graph? Right 4 and down 6. So standard form is really easy to use when you're finding the roots. But vertex form helps you find the vertex. So let's do another one. Okay. So I'm going to force this to be x plus something. In order to do that, I'm going to move the 17 out of the way. What's going to go in the factor? 6. So if there's a 6 on the inside, what do I put here? 36. And if I add 36 to one side of the equation, then I'm going to subtract 36 over there. So that graph is left 6 and down 19. Okay. Now, that's all pretty easy, but sometimes it's a little bit harder. Nope, that won't work. Yes, it will. So, same idea. X squared minus 5x, slide over the 6. And now we have x minus what? Well, I need to cut that 5 in half, which is 2.5. And then I need to square it. Does anybody know 2.5 squared in their head? I don't. So let's just leave it in fraction form. What is 5 over 2 in fraction form? It's just 5 over 2. The reason we do that is squaring a fraction is really easy. It's just top times top divided by bottom times bottom. So this is 25 fourths. So over here I subtract 25 fourths. What is 6 in fourths? 24 fourths. So 25 over 4 minus, 24 over 4 minus 25 over 4 is just negative 1/4. So that would be the vertex form. So if your middle term is odd, just stick with fractions and it'll be easier to solve. If you use decimals, it will work, but fractions are a little bit easier. Okay, now you ready for a hard one? Because they do get harder than that. What about this? Now, I might change this number. I just made it up, and I might change it later. So, this is a problem. Completing the square relies on that leading coefficient being a 1. If it's not a 1, then we can't complete the square. So, we're going to make it be a 1. The way to do that is we group these together, and then we move the 17 out of the way. But we're going to pull a 3 out of the first two. So y equals 3 times x squared minus 4x, and then there will be some number there with a plus 17 at the end. Okay, so y is 3 times x minus what? 2. And then 2 squared is 4. And if I add 4 pounds to the left side, I need to subtract 4 pounds. However, I didn't actually add 4 pounds. Look closely. I actually added 12. It looks like a 4, but its effect on the equation is a 12 because that 4 is hiding underneath a 3. So by adding a 4 on the inside, the end result is a 12-pound addition on that right side. So when I subtract it off, oh, I picked a good number. I'm going to subtract off 12. There's plus 5. So where is this equation? It's right to 3 times as tall and up 5. Okay, let's do another one. And I have no idea what to put here. I'm just going to put that, and well, we'll probably change that later, but same idea. I'm going to pull out a negative 6, and I'm going to slide the 15 over. Everybody good with that? Okay. Good there? So I put a plus 9 in there, but it's not really a 9. I'm going to change that to a 45. So that 9 actually is a negative 54. So to undo that, I need to add 54, and I get a plus 9. We good? Okay. Now, what if I had x equals y squared? What would that graph look like? No, so y equals x squared is a happy parabola, and y equals negative x squared would be a sad parabola. Yeah. So the x and y roles have flipped. So we need to aim in the direction of the positive x's. So this would be a parabola that opens to the right, and x equals negative y squared would be a parabola that opens to the left. Okay? So if I had what would that look like? Well, our x's and y roles have switched. So this is going to affect the y-axis, and it will be backwards. And this will affect the x-axis, and it won't be backwards. So what does y plus 3 accomplish? Up 3. Okay. What is timesing the x's by 2 going to do? Twice, yeah, so maybe we'll call it long. So multiplying on the outside of an x squared parabola makes it taller. But now we've shifted left and right, so it's going to make it wider. And then what effect is that going to have on it? So that would be right 1. So we have a, I don't know, skinny, tall, I'm not sure what you would call that. But it would be a parabola that opens to the right. Okay, think you can handle that? Okay, and then lastly, what if I had this parabola here, and I asked you what is the domain and what is the range? Do you remember what domain is? Domain would be the x's, good. So if I draw a line through the x-axis, if I move that line around, when do I hit the graph? So if I were to just grab this line, does the line touch the graph over here? Well, let's pretend everything goes on forever. I'm going to touch the graph way down below my feet, okay? And then I hit there and there and there and there. Do I hit over here? So do I ever miss the graph? Nope. So in this case, the domain is all real numbers. Okay. For the range, I draw a horizontal line. When does that horizontal line hit the graph? So does it hit down here? Yes. Hit, 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 hit. What about up here? No. Right. So what we say is y is smaller than or equal to 1. Okay. What if I had this parabola? What would the domain be? All real numbers. What about the range? Y is greater than or equal to -4. Now, how do I know that this is actually equal to -4? How do I know it doesn't just slightly miss it? The answer is it always hits unless they tell you otherwise. So the only way to get rid of this equal to would be if there was an open circle there that represents a gap or a hole in the graph. When you look at 2.6b, there are several questions dealing with circles. Don't worry about the circle questions. Just do the quadratic questions. Okay? And then next time I'll teach you how to do circles. Once you get good at quadratics, then we can do circles. All right, get to work.